eighth graders. Today we're going to be doing a lesson about relations and functions. So we're going to start with some new vocabulary terms. So up here at the top we can see it says ordered pairs can be used to show inputs and outputs. These are two of the new vocabulary terms that we will be talking about in this chapter. So looking at this picture here, we can see that we have three ordered pairs. Our inputs are highlighted in blue, and our outputs are highlighted in red. As we can see, the inputs are the x values, and the outputs are the y values. Our point is written as x comma y in parentheses. The first number is the input value, or the x value, and the second number is the y value, or the output value. The next definition we want to go over is a relation. A relation pairs inputs with outputs. A relation can be represented by ordered pairs or by a mapping diagram. Here we can see that there is a set of ordered pairs. This is what we would call a relation. It's pairing different inputs with different outputs. And we can also show it using this new tool called a mapping diagram. A mapping diagram is very similar to a table, except that we use these arrows to show which input matches up to which output. So we will see diagrams like this throughout this chapter. They are different than a table because of the arrows showing the inputs that match up with the corresponding output. Now, these are not the only two ways to show a relation. We can also show a relation with a table. We can show it as points on a coordinate plane. We can show it with words. And we can show it using an equation. In this section, we're going to focus mainly on ordered pairs, mapping diagrams, and we're also going to throw some tables in there. So remember that a relation just pairs inputs with outputs, okay? So it's a set of inputs that are paired up with a set of outputs. Let's move on to example 1. Example 1 asks us to list the ordered pairs shown in the mapping diagram. To do this, we are simply going to, in parentheses, list our input first. We can see the input is 1, and then we're going to list the corresponding output. There's an arrow pointing to 3, so that is the output. When we are writing this as an ordered pair, remember the input comes first and the output comes second. The next one would be 2, 6, 3, 9, and 4, 12. Now in our second example, it gets a little bit trickier because each input is not corresponding to the output directly across from it. Okay, so we can see that this first input listed is 0, and the arrow is pointing here to 0. Okay, so the corresponding output is also 0. The next one, we have this input of 2. Now there are 2 different arrows attached to the input of 2. So this is going to be 2 different ordered pairs. The first would be 2, 1, and the second would be 2, -2. The input of 2 has two different outputs. It has an output of 1 and an output of -2. So that should be written as two separate ordered pairs. And the final one would be 4, -3. 4 is matched up with the output of -3. Okay, so this is how we can list ordered pairs that are given to us in the format of a mapping diagram. Now, before we move on to example 2, there is an important definition we all need to know, and that is the definition of a function. So a function is a relation that pairs each input with exactly one output. Okay, so when we're talking about a function, each input should have exactly one output. So now let's look at example 2 and determine whether each of these relations would be considered a function. So first we will look at example A. I can see that -9 has one output of 0. -2 has one output of 5. 5 has one output of 10. And 12 has one output of 10. So we would say that yes, this is a function. And that is because each input has one output. Now let's look at example B. We have this list of inputs here. Let's check to see if each of these inputs has one output. So we have -2 has one output of 4, -1 has one output of 3, 0 has two outputs. 0 has an output of 5 and an output of 6. So we can stop there. Because that has two outputs, we know that no, not a function. And when we explain that, we're going to say 0 has two outputs. All right, so the input of 0 has two different outputs. It has an output of 5 and an output of 6, so no, this would not be a function. Now, like I said, in this section, we are also going to see some of these shown as tables instead of mapping diagrams. So if this information were to be shown in a table, I'm going to show you what that would look like. So I will still have input here and output here. And I'm going to list my ordered pairs. So -2 matches up with 4. -1 matches up with 3. 0 matches up with 5 and 6. Okay, so we're going to, just like we did with ordered pairs, we're going to write this as two different rows in the table, 0, 5 and 0, 6. Next one is 1, 6. And we have one more, and that would be 2, 7. Okay, so this is what this would look like if we were to have it in the format of a table. It's similar to listing the ordered pairs. okay? And what we want to look for to determine if it is or is not a function when it's in a table format is a doubling up of the inputs, okay? So we already discovered that no, this is not a function. And what we want to notice here is this input of 0 is repeated in the table, okay? So if you're given a table instead of a mapping diagram, you need to check to see if any of your input numbers are repeated. If you have a repeated input number, then you know that no, that is not a function. Okay, this input is repeating because it has more than one output. It has the output of 5 and the output of 6, okay? So a repeating input shows us that it is not a function. Finally, let's take a look at example 3. Part A says determine whether the relation is a function. The input of 1 has an output of 15. The input of 2 has one output of 30. The input of 3 has one output of 45. And the input of 4 has one output of 60. Each of these has one output, so I'm going to say yes, each input has one output. So we know this is a function. Okay, and now part B. It says describe the pattern of inputs and outputs in the mapping diagram. So when we're asked to describe the pattern, this is similar to what we have been doing over the past week in our Do Now problems. Okay, we're describing what each of these inputs and outputs are increasing or decreasing by. Okay, so I'm going to look at my inputs first, and I can see that inputs are increasing by 1 each time we are adding 1. And my outputs are increasing by 15. Each time there is a jump, we are going up 15. To describe this, I'm simply going to state those two things. As inputs increase by 1, outputs increase by 15. Okay, so that is how we should go about describing the pattern of our inputs and outputs. What are the inputs going up or down by? And as they are going up or down, what is happening to the outputs? All right. That is it for this section. Please head over to ClassCake to work on your practice problems.